Hey guys, this is Kate with Beach Moto. We're doing another episode of Ask an Expert, and today we are talking with the SNELL Memorial Foundation, and I have Hong with me. Hong, thank you so much for joining us.
Thank you for having me, Kate. It's great to have this opportunity so we can actually have a direct conversation with the people we serve here.
Yeah, I'm glad that we were able to make this happen. So tell us a little bit about SNELL. How did SNELL came to be? When did it start, and what was the original purpose of the foundation?
The very beginning, the establishment of this nonprofit organization can show you what the mission really is about. In 1956, Pete William Snell was the Racer of the Year of the San Francisco chapter of Sports Car Club of America. And he died of head injury when his race car turned upside down and he had a massive head injury. Because he was such a noted person in the racing society, and he was young and very much loved by the community, a lot of money was donated to memorialize him by the chapter, and they named it Snell Memorial Fund. And as the race group, the Sports Car Club of America, talked about what to do with the money, one of their board members is Dr. Snively, a medical doctor with an engineering background, proposed to set up the Snell Memorial Foundation to dedicate this funding as a seed money and start working on understanding and set the head injury and set up a helmet performance standard to evaluate helmets so future racers can have a choice of wearing more protective headgear. That's how this organization was set up the year after Pete William Snell died. US had zero standard, which means nobody was evaluating helmets and see how well they do. So there was a lot of early work to do, like how do you test a helmet? What instrument do you use? What kind of a test methodology is scientific? So you can really say, this way we test it is valid. It's going to pick out the better helmets, right? So once that was set down, what the racing community did was to support the first SNELL standard, which was issued in 1957, 2 years after the organization was in operation, that all the racers participating in the race sanctioned by Sports Car Club of America, they all have to wear SNELL certified helmet at that point. So all the manufacturers who did not make the SNELL certified helmets start to emulate and start to make those helmets and try to sell these to the racers. Every SNELL certified helmet had to be tested at the SNELL lab. So they pay testing fee. We don't get any money from the public government source. It's totally self-funded through people buy SNELL helmet. And
Gotcha.
because they buy, the manufacturers feel they have to stick to this higher performance standard.
Good.
They
And
between us.
yeah, and it's interesting to see that you guys are that, transparent about all your business operations. I think it gives people confidence in what you guys do and what you're about. But let's talk about the actual testing itself. So you mentioned that, at the time when you guys started doing this, there was no testing. So how was your test developed? I guess who was it developed by, and did they use like real accident data to figure out how they're going to test these helmets?
At the beginning, what we need to understand is what kind of injury are we trying to prevent with these safety devices, right? So in the case of motorcycle helmet, is really high level of impact energy. And with just the high school physics, we understand energy is constant. Once the energy is there, it has to go somewhere. So in a crash situation, basically what hurt the person is not how fast the cruising speed was, it's how suddenly the body, whichever part of the body was impacted and end up in a sudden stop. So the
Okay.
change of momentum is the shortness of the time that all the energy was released. So what the helmet does is to absorb as much energy as it could by design and by use of material. So the testing is really trying to measure how much this helmet can absorb the amount of energy. So when I go to the lab later, I'll show you that how we measure how much energy was put into the helmet, causing like a free fall in our test lab, basically. Upon the impact, the dummy has a sensor to tell us how much acceleration is coming to the end. And so how much the helmet did and how much it didn't do. So we use those numbers which translate into G-forces to evaluate. So we know the human tolerance for impact to the head should not exceed 400 to 600 G, which leads to serious brain injury or even fatality. So we set the threshold at used to be 20 years ago, 300 G, which is 100 G less than the D.O.T standard set at 400 G. And now our standard G-force requirement is dropped to highest is 275 and lowest is 243.
Oh,
Basically
wow.
trying to reduce the G's that goes to the head and increase the severity in the fall. And that's how we call out more protection capability.
Gotcha. So we actually did a similar interview with Arai helmets last week, and they're very, heavily focused on safety, and all of their helmets are SNELL approved. But one thing that they talked about that I don't know if SNELL addresses is the rotational forces in an impact. So is and for Arai, it is really important, and that is why they talk about the shell being round, so you can release some of those rotational forces. Is that something that SNELL does test for? And if not, do you have plans to test for that in the future?
That is a valid concern because we do not have a test for that yet. But the reason is very complicated. Let me put it simply this way. When we measure something, we should have a valid way to measure. For instance, if we have a ruler, we can measure the length, right? And when we measure a curve, we have an arc, right? So we have all these geometry kind of tools to measure like how many degrees and this and that. So in the sense of a rotational test, you need multiple sensors in the dummy to measure movement in every direction, okay? So right now, there is no reliable tool to measure this way. And so whatever people claim out there, like, oh, this reduced rotational impact force, is just a claim that nobody can really scientifically repeat it. So
Mm.
when you say, oh, this reduce this from this to that, and you do an exact test on the exact same helmet, on the same equipment, you may not get the same reading. That's
Gotcha.
the current situation. So we have helped to hold international workshop with PhDs and postdoctors from multiple countries in international conferences. The last one was held in Paris, in Lyon, France. 39 high-level scientific people came together and talk about how they try to measure with their own design and instrumentation, and nobody can agree which one is really, truly scientific and repeatable. That's where we are
Interesting.
now.
Interesting. Okay. Well, yeah, that's good to know because now there are so many new technologies coming out, that focus on, we reduce the rotational impact, but I would be curious to talk to them and find out how they do the testing if you're saying there is no measurable way to do it.
Right.
So another thing that I learned while talking to Arai, and correct me, if this is wrong information, but I was always under the impression that SNELL only tests full face helmets, but according to them, you guys do have a different type of test for open face helmets. Is that correct?
No,
Oh,
open face helmet, like what we call is a 3/4 helmet, right? Not the
yep,
half helmet, because the
right.
snow test area on the head in the back is much lower than what the half helmet can manage. So half helmet, you can just assume automatically no SNELL certified helmets. 3/4, like what the CHP wears, is SNELL certified. And
Okay.
what it doesn't have is the chin guard. The chin part is obviously not there. So in the SNELL motorcycle helmet standard testing procedure, if there is an integral chin bar, then it will be subject to chin guard test. So in the open face helmet situation, it's not tested. And because
Okay.
everybody knows there's no protection there. We
Right.
test something because it is perceived to give certain level of protection. So
Okay.
full face helmet, yes, most of the SNELL certified helmets are full face helmet, but they are open face 3/4 helmets that are SNELL certified.
Okay. So, and then when it comes to like modular helmets that do have a chin bar, I don't think I've ever seen a modular helmet that's SNELL certified. Is it because that you have tested modular helmets and none of them pass, or or are they not certified because you don't currently have testing for modular helmets?
It's not that we are against the modular helmet design idea. It's that we, as a standard organization, we are working for the benefit of the rider to basically be the gatekeeper and only keep those helmets that we consider we can recommend, right? So when we test these modular helmets, we hold it to just as a high standard as all the other helmets, open face, or like open face, the impact test is identical to the full face. Everywhere we can test the full face, we will test on the open face, except the chin bar test is not done because there's no way to do it. And
Mm-hmm.
everybody knows they're taking the risk, okay? But with the modular, people look at it as if it's a full face helmet. So we will have to test it as if it's a full face helmet.
Mm-hmm.
So it will be subjected to all the full face helmet test requirements and criteria. And the fact is that because this jar moving part can open during an accident before the whole accident is over, we also require that the chin bar, even if the impact is over the head, the chin bar section of the modular helmet had to stay in a lockdown position for the first 3 impact of
Okay.
all the impact that we do on the helmet, which we do 8 for each helmet sample.
Mm-hmm.
So because these helmets fail, any of these can be a elimination cause. They just can't make the cut. So most common that we've seen is during the first 3 impact, these chin bar will open up. So
Gotcha.
it does not really give the perceived protection of the chin area. The other way that these helmets tend to fail is the temple area, where the housing gear for the rivets for moving these chin up and down
Mm.
is
Mm-hmm.
made of hard plastic. And hard plastic is material, any material in the impact can absorb some impact energy, but it's not doing the best as the foam, which is a lot softer and cushion the brain much better. So because when you test the helmet, it's subject to the test technician's choice of where to impact the helmet, our test technician will always pick the most vulnerable spot that the standard allow you to test.
Right.
So say in case of these modular helmet, right here where the rivets go, where they hollow out the shell to put the housing gear, how to house the gear movement, that's would be definitely chosen by our tech technician to see if this is where they cannot pass.
Okay. And would that also be the case for helmets that have a drop down sun
Yes,
visor? Okay.
yes.
So,
That same reason, the storage space for this drop down sunshade takes away a good at least 3 millimeter of foam and shell. And so when we hit the helmet harder in our drop test, when you take away anything, it's a risk of failing the test.
okay.
So that's why all these design now are resorting to only DOT, because DOT does not call out as severe a crash as we do. So they
Okay.
can manage.
So speaking of DOT, and again, this could just be a rumor, but from what we understand, DOT doesn't really have like testing facilities, and a lot of times the manufacturer like signs some sort of paper saying that if you were to test our helmet, it would pass your standards. From your experience, does DOT do any testing on their own, or are they relying on the helmet manufacturers to do the testing?
Primarily only the manufacturer, because DOT standard, like all federal safety standards, are self-certifying standards. So basically, when the federal government issue a safety standard, it always trusts the manufacturer of the product to test and make sure the product meets the government standard. From the government point of view, their primary the duty is to set the standard and publish it, basically telling the manufacturers, hey, here is your responsibility if you're going to make this product. You don't have to send the product or its prototype to a government entity to pre-screen or test before you market it. When you market it, you should know your product should meet the standard the government sets. That's basically how it works.
Okay.
But when these products actually, because of a design failure or manufacturing cutting corner or other, substitute of material, whatever, down the road, it start to fail and not be safe enough, it will show up in accidents and all that. And when there's enough of these, then the government does start these investigations. When the investigation confirms the reason or the part, then they start recall. That's how the safety standard of US federal government works. They do in motorcycle helmet, random sample 40 models. And and it was contracted out to outside commercial labs to do.
Yeah, that's a little unsettling to hear about the DOT testing, because we have so many people that, they'll buy a $30 helmet on Amazon, and come in and try to convince us that it's just as good as a SNELL-approved helmet because it's DOT approved, but who knows? I mean, you would like to think that there's no like deceiving manufacturers that, just claim it's DOT approved and it actually isn't. But in this day and age, I wouldn't put it past them, so I would feel much safer knowing that the helmet I'm wearing was actually tested by someone other than the manufacturer. That's very unsettling. So you mentioned earlier that SNELL publishes the information from the testing on the website. Now, does SNELL do helmets as pass and fail, or do they actually get some sort of grade, so a person can see which helmet tests better than another helmet?
Yes, every SNELL certified helmets test the results, because we not only just in the beginning, we do the certification test, like who passed the grade, right, in every aspect. and then they get on this SNELL certified helmet list, which we do publish on our website. The sticker on every helmet has a serial number. So we actually know which company is making how many helmets. So based on that sticker cell information, we conduct a random sample test, which means every 2,000 helmets that specific manufacturer made, I will buy. I'm actually the person who also acquires these helmets from the marketplace and bring them back for random testing. So
Oh,
basically, that is part of the whole bargain. If any manufacturer voluntarily join the SNELL program, they should know not only their helmets by design and manufacturing has to meet a higher bar, they will also subject their product for constant monitoring of the performance of these helmets sold in every store out there. They don't know when and where I'm going to grab that helmet back here for testing. So basically, somebody's always looking over their shoulder.
oh
And,
wow.
and that is the comfort that every helmet user should know. When you wear a SNELL certified helmets, somebody has already tested in the beginning when the helmet was brought into the market in the first place. And then all year round, somebody is monitoring. So you don't
Interesting.
have to guess which helmet is going to do a better job. So that every SNELL name on the helmet basically is SNELL Foundation's uh, recommendation that we recommend this helmet and we know it meets our standard.
Gotcha. Okay. And then, so you guys upgrade the test every few years now because, you know, we see SNELL certified such and such year, and then a few years later, there will be a new certification. Do you actually change the way you test the helmets within that time period?
Yes, usually every 5 years, these standards gets a review because we get to test all these good helmets. We know what options are in changing material that could improve certain area of performance. And we uplifted those standards when it's possible. And that's how these standards published by SNELL gets tougher and tougher. Whereas the DOT standard, when it issued in 1974, I'm sure it's older than you and all these younger writers out there, has never changed.
Really? Has
Yes.
not changed since 1974.
Right, in terms of
Wow.
how protective and how it works against impact, it has never changed. But there is a place for minimum government standard because without a government standard, then anything goes, right?
Right,
So
right, of course.
for whatever reason, somebody had a hard time buying a SNELL certified helmets or unwilling to buy for whatever reason because they say they want a modular helmet, do consider a reputable company that has been around and has a lot to lose, because part of the problem with DOT is not just the standard is not very demanding, it's old, but also that you don't know if it's DOT or not.
Right.
A lot of helmets that do not meet DOT, nobody knows,
Right.
you know.
Yeah, that's
So at least when you go for the reputable company, I would say you should have the more assurance that at least when they say it's DOT, it does meet DOT. Other than
right.
that, you really don't know what you're getting.
Right.
And
Yeah,
but with
it's a little
SNELL
scary.
certification, you know you're getting 40 to 80% more protection over and above DOT. And we have test data to show that.
Gotcha. Well, I would love to see some of the testing that that you guys do. So I know you mentioned you might be able to show us some portion of the lab and how the testing is done. I'd love to see that if we can.
So hi, we're in a SNELL conference room here. I want to show everybody this helmet used by Pete Snell on that tragic day when he crashed. See, it looks like a riding helmet. And of course, with English tradition, this helmet was actually made by English company called Cromwell, very popular model at the time in the 1950s. The brown colors tear open of the inside. You can see scuff marks on there. And the SCCA, let me see, I'm trying to orient it this way. The SCCA label, you can see the San Francisco chapter racing. And
what kind of material did they use back then to make that helmet? What is that made of? Do you know?
it's cardboard paper. That's what
What?
this, yes, it's paper. You see this
Oh my
crack?
gosh.
And the white, it was white leather bonded, and the inside is cardboard paper. And it has a suspension
Wow.
system, which is bloody here, if you can see this brown stain. And buckled, it has a kind of suspension system like an industrial hat today to really circulate some air to make it more comfortable, not too hot. And that's all there was. Okay.
Wow, that makes me feel so much better about the helmets of today. And but it
Yes.
also makes me think about how crazy, you know, racers were back in the day when they wore helmets, cardboard helmets apparently to race motorcycles
Yes.
and cars. That is insane.
So I'm going to walk you to the lab as we show you how the lab is functioning now to make all the testing to demonstrate how these helmets can be protective, a lot more
Awesome.
protective than the minimum standard.
I'm
Okay.
excited. I'm excited to see it.
Here, this workstation is basically a robot here. This is a robot that determines these lines that we get on the dummy. These are
Yep.
different dummies here. Because on every helmet, we have to test them in certain impact zone, right? So this is where we treat everybody equally. We draw up the line here and make sure the vulnerable spot within these lines get smashed.
Now,
And
do you
the
have
is going to tell us.
do you have different size like models based on the size of the helmet?
No, these are called international standard, organization standard. They go by different size by millimeter, centimeters, okay?
Mm-hmm.
So when they're manufactured, when they sell them, they call it small or medium or large. They can call whatever they call, usually within a range, not
Mm-hmm.
exact centimeters or millimeters. So what we do here is try to make sure we know that helmet, whatever they call it, get onto the appropriate size helmet dummy.
Okay, so they are different sizes.
Yes.
Okay,
So
great.
here, so for instance, I can show you is 1, 2, 3, 4, 5, 6 different
Mm-hmm.
sizes. Okay.
Okay.
Yeah. And we have all these helmets from different factories here waiting to be tested.
Wow. How many helmets do you guys test like per year, as an example?
About 3,000, I would say.
Wow. Okay.
More. And so here is Tanner's test stand here. You see, I want to show Tanner is got this helmet up on the here. He's picked a spot to test. Let me show. Yeah, see the laser point spot is where the intended impact site. And we have laser because we drop it twice and we want the first and second drop overlap exactly. So you don't favor the helmet by shifting locations. So the same liner and shell gets smashed twice.
Okay.
So
And
want to
it gets
drop it?
smashed twice in the same spot, you said?
Yes.
Okay.
So this is like a shaft here, like a chimney. it gets raised high by this bar. And then when the computer knows exactly where it is, it will release it and smash down to this surface here.
So like that.
This one is a hemi. So
Mm-hmm.
yeah, that's a hemispherical. It's very kind of like a fist and punching into the liner. It's the most destructive anvil here. But we do impact it on different anvils as well. So I'm going to show you here, like, let me see, on the table here, we got this edge, this one. It's more like, you know, the guard rail on the highway,
Yep.
you know.
Yep. Mm-hmm.
And we got the flat, like the pavement.
Right.
So these and that hemispherical one. So all these three represent the various shapes. So anything in between should be okay if the helmet tests are all right on these three for motorcycle.
So each helmet gets tested on each one of those surfaces?
Yes.
Okay.
Okay.
Now, do the motorcycle helmets go through a different test than the automotive helmets?
Very much the same, except
Okay.
the automotives has a flame test.
Right,
so that
yeah.
the fire retardant material must be used for these tests. So it
Gotcha.
can't, you know, catch fire and keep burning like a furnace.
Gotcha.
But
Okay.
for impact levels, it's about the same, except I think motorcycle, auto racing, they also have an anvil that's called a roll cage, like this bar, like this round bar.
Okay.
That's like the bar around the
Yeah, the car
driver
frame.
in a race
Right.
car that the helmet can get, like impacting it multiple times, you know.
Gotcha. Okay.
That's not on motorcycle helmets, but it's not a much more severe situation than these hemi impact though.
Right, right.
This is the nasty one. Okay. So are you going to drop it for us?
Yes.
All right.
You're ready.
Okay.
All right. Just take the safety down. We are good to go.
All right. Now he's going to raise it to the higher height. All right. I'm trying to catch it on my camera. You can see it, right? Am I safe here?
I would step back a little bit.
Okay. I'll just let you guys see it's coming down, not from the top. Okay, I'll
Okay.
step back.
No worries.
What about if you feel the helmet hits the actual anvil?
Okay, I'll put the camera right up on the anvil. Where is it?
Yeah, where it hits.
I'm not used to use, there,
A little lower.
there.
Okay, perfect.
See the anvil is there?
Yep, yep.
So you're going to hear it coming down, okay?
All right.
Okay.
You ready?
Yep.
Yes. All right.
So then you raise it back up and do it again
So-
immediately in the same spot?
Yes, and I will show you what the passing grade here. See, this is the test result curve here for this impact. See here, the impact starts, and this this XXO is the time. These are milliseconds, 1/1000th of 1 second time. So by
Right.
the time it's like about 5 milliseconds a second, it has punched through and all the impact is complete. Actually, this is just the rebound. So that has reached like 184 peak G. That's the G force that if there's a human head in there, that's like, wow, I really got hit. but
How
I'm
many,
okay.
how many G's was it? 184? Is that what you said?
Yeah, can you see?
Yeah,
You're probably
184.
seeing
I
it
see it now.
backwards. Yeah, 184. Yeah.
Okay, but 184 would still what pass, first of all,
Yeah,
because
we'll
you.
pass, definitely,
Okay,
yeah. For
yeah,
us here, the passing is 275, right?
right.
It's 300.
Uh-huh. Okay.
So yeah,
All
you
right.
might end up
So
with
we're
some sort of concussion with that kind of G-force, but probably survivable.
not really. That's another thing I didn't talk about when you talk about rotational force and concussion.
Yeah,
There is no medical evidence and data to like correlate how many G's you're going to get this and that kind of impact related other injuries, including concussion.
really.
So we have two problems here for setting standards. One is whether the test is repeatable. Second is what level are we preventing? Say if we know that anything over 100 G is going to relate to this and that kind of injury, and so we should set 100 G for a criteria, right? That would be the logical conclusion.
Yeah.
We don't have that data. No, that rotational force at certain level would lead to certain type of injury. So the current assumption is even without the rotational test, these current helmets must have provided some level of impact protection already. Otherwise, not everybody's impact is square in the middle, right? But at least this way we're testing it, it's repeatable. We know exactly what we are measuring, and we can measure it reliably well. The same helmet, no matter how you're going to test it under the same condition, you get the same reading. Because if without that repeatability, you really don't know what you're measuring, how you can compare from that.
What do you guys say to like I've heard some people say that you rarely, I guess, hit the same spot twice in like a real life situation. I'm sure that you've heard that before from
Yes.
people. So
I
what's your
understand
response to that?
The response to that is the idea is what we do here in the lab is not an attempt to duplicate impact real situation. What we are doing here is really conduct some measure that's repeatable to get the highest level of the quality that we push for. So in the event that we are testing like this, very rarely anybody hit exactly the same spot. But what we are trying to do here is to measure and see how much total capacity this helmet can withstand and manage. Because we have a limit of our building here even. We have to cut a hole in our roof to get this drop height higher, to reach the higher velocity that we trying to accomplish. So when we cannot do that anymore, we live in the real world, and we need to create this force of impact. So do it in one go, we do it in two hits. Here?
Yeah, I hear you. And
Yeah.
what is the distance that you guys are using? The drop distance?
The drop height right now?
Yeah.
I think it's we can look at the data here. I know what they're trying to accomplish is 8 point. Okay.
It was 3.763 meters.
Okay.
Okay.
It's 3.763 meters.
Gotcha.
So
Which
it's
is
more than 10 feet.
Yeah, which is with the DOT standard is like 10 feet or something, right?
Yeah, this is certainly, if you can see, this is the very top of an industrial building's second floor roof. And
Right.
we raised that roof already. There's a doghouse on the top. when we changed the standard in 2010, there was no room for any more severe impact.
Gotcha.
So we had a hole cut in the roof and raised the impact. Yeah.
Gotcha. Well, cool. Is there any other cool stuff in the lab that you wanna show us, or was that pretty much?
Yeah. You want to do? Yeah. Another thing is, everything we do here is to really check how the helmet building capacity to protect the brain well. One thing as a user of the helmet that what you should do is to find the best fitting. So you can really improve the protection by finding the best fitting. And we always recommend people to go into a real store. Don't just go online and buy whatever good deal you're going to get.
Amen
if
to that.
the helmet doesn't fit you, and you're really giving up some capacity that better fitted helmets can really provide you. Okay. And the other thing is, after you get the good fitting helmet, is buckle it to allow only 2 fingers go under like this when its strap is tightened. Because we go through the pain and work here, let me show you here, is to test the chin strap here.
Oh, wow.
Okay.
Okay.
See these 2 bolts where the chin strap looped over and being yanked and tested, it's like the jawbone under our chin here. So this whole apparatus is designed to give this whole buckled structure a severe yank. Like an accident happens and this helmet will stay on and hold on to it and nothing breaks loose. So the helmet's going to be separated from the head. Okay.
Wow, I had no idea you guys test that.
Yeah, we test every aspect. So go to the SNELL website or YouTube to watch that video. You'll be amazed how many different things we test. Okay, he's going to do it. So Tana, take it away.
Maybe angle your phone a little.
Okay, like this.
Right there. I think
okay.
That's good. All right, here we go.
Did that stay on?
So what happens, is when the helmet is correctly buckled and this whole steel mask get dropped and yanking the whole system. So we have different ways to measure, like the strap cannot elongate like too spongy, that gets too long. And we have a linear measurement to see how long it's stretched. And also the rivets cannot be pulled out. The D-ring cannot come loose. The sewing had to stand. So all of this is part of the evaluation of the strap system. Here is the computer reading of how much the strap elongated. And if it's exceeding the 30, was it 30 millimeter, then it fails.
Okay.
So this limit the way they use certain material that is not too stretchy.
Yeah, I think people underestimate.
Okay.
The importance of properly strapping your helmet.
Yes, and here I think this is ready for a chin bar test. Let me.
Oh, okay.
Okay, here the chin bar for a full face helmet gets weighted, smashed down, and we'll see how much this chin bar can stay stable or not intrude into the chin area.
Okay.
People can have it, don't have to pay an extensive dental bill.
Yeah.
So I'll let Tana drop that.
How much
a
weight?
modular helmet would have to pass this one too, just like this full face one.
Yeah. How much weight is that falling on the
Uh,
helmet?
it's 4.36 kilogram.
Okay,
Overall.
Overall is 5 with all the other hardware on there.
gotcha. Okay.
So basically, it's like somebody gets airborne off the bike and kind of drop down to the ground from like, a few feet high, and you hit the ground with your elbow and and then your chin goes down.
Well, I really enjoyed that tour, Hong. Thank you so much for speaking with us and for showing us around. I am definitely more sure now than ever that I am going to be wearing a SNELL helmet from now on. I do think that the amount of extra safety provided over helmets that don't have the SNELL approval is significant. So thank you for showing us and, for giving us a little bit of history on the company. And as Hong mentioned, check out the SNELL website for other videos demonstrating what they do in the lab. And I guess they can find their helmet test results there as well, if you want to see how your helmet did during the SNELL testing. Hong, any final last words?
I thank you again, Kate, for this opportunity so we can reach out and give this safety message to all the riders there. That's all we want, is for them to be safe. And every time they put on a SNELL certified helmets and buckle it securely and enjoy a ride, is a pleasure for everybody. And that's the whole point of our work here. And I thank you, everybody, for supporting what we do by choosing SNELL certified helmets. Without your support, even though the manufacturers have good intentions to make good product, it may still just be DOT. Thank you.